Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
So what we can do maybe is, Abdul, if you wanted to give a little background on your outlet, I know that you had suggested some things that we should talk about to interest your readers, and then maybe that will help Stéphane kind of pivot the conversation to see if, what he can offer about Kalray and what he can talk about Kalray that makes sense.
Well, Robotics and Automation News.com is our main thing, the website. And having done a little bit of research, we find that the largest group are engineers or engineering sort of oriented companies. And the second largest group, surprisingly for us, was investment experts or companies. Where I think, well, having seen your website, where I think, some of the interesting things, I mean, definitely people are interested in autonomous driving, not just in terms of the research vehicles that are level 5, sort of totally driverless, but also new cars that have advanced driver assistance systems, which, to some extent is autonomy. I know some of them are level 2, 3, and possibly even 4, I think. But I don't know. I mean, you can tell me. But it is very interesting. It's a very interesting area. It's a growing area for us. We used to have more readers or more enthusiastic readers for industrial robotic arms and factory-based robotics, but autonomous cars and related technologies are very fast growing for us as a readership. So that's why I think it'd be great to hear an insight about some of the things that I suppose Kalray does and some of the technologies it has.
Okay, so first a little bit of introduction about Kalray. And so we are a French company. We are about 10 years now old, and we recently have an IPO at the Euro Stock Exchange, so on the Euronext, and so we raised about 50 million euro during this IPO. So, and this IPO also came with the arrival of some key partners at the shareholders, and one of the well-known is Renault, Nissan, and Mitsubishi Alliance. So we've got this shareholder arrived. I mean, it was just before the IPO or at the IPO more or less. And also we've got BPI France is the to say it's the French government bank, more or less, because Kalray is also has been identified as a strategic company for Europe, in the sense of because processing is very important for the European community, as you can imagine. We are mainly located in France, as I said, but we have also an office in the US, in California, because you have a lot of our customers over there, and also in Japan, because we have also some customers over there. The main goal of Kalray is developing a new kind of technology, which is a new kind of processing technology, which is based on the fact that today we are coming with a completely new era in terms of processing, and as you know, we are all connected, and each of us are generating a lot of data every second, and then we have seen the need of processing all this data, and this is important to process it in the real time. And when we go in a product like an autonomous vehicle or even a robot, it's even worse, because the real time means that it's a safety point of view behind the real-time processing. So you have to be able to process real-time, a lot of data in real time. And this is the really complete new things compared to mobile phone or even to standard computer. So for that, we need new technology, and this is where we are focusing today. So this is the two main area where Kalray is focusing. So we see our technology very powerful for these two markets. The first is what we call the intelligent data center. It's basically the back office of all the IoT that are connected and gathering the data. And you need to treat it, you need to store it, you need to manage the data at very fast speed. And this is what we call the intelligent data center. And here, Kalray is very efficient, very powerful, for example, on the smart storage. As you know, today, all the storage move from the hard disk drive to a flash memory kind of storage, which is very, very fast new technology. And for this very fast new technology, you need very fast processor to be able to manage and treat all the data. And very similar, but more on the embedded world, is what we call the intelligent embedded system. Is basically the same requirement. You need to you have real-time data coming from sensors. So in the car, for example, is coming from a camera all around the car, or in the robot also from the camera or from different sensors you can have in the robot. And then you need to treat it because you need to analyze what is around the vehicle, what is around the robot, and then take decision to drive the car, for example, when you don't have any driver, or to do some task when it's a robot or when it's a drone or whatever. So this is really the two area. So it seems to be different, but in reality, what is behind for the data management and for the processing is basically the same kind of technology that we need. Can go to next slide, Alison? Thank you. So one important thing to notice is that Kalray is a fabless. So we do our own processor, but we just design it. All the manufacturing is outsourced. And of course, we are working with one of the big players in the world, which is TSMC, so Taiwanese company, one of the biggest Taiwanese wafer foundry company in the world. And so this is very important for us because we have access to the very up-to-date technologies, manufacturing technologies, and we can have the same access to the big player that you can imagine in the processing, like Intel, for example. So thanks to TSMC, we have access to the same advanced technology. Next slide. Thank you, Alison. So a little bit of outcome on Kalray. So as I told you, we are 10 years old. We are coming from yeah, sorry. No, it's okay. We are coming from CEA. So CEA is a big, let's say, governmental laboratory. It's very similar to DOE in US. I don't know if you have equivalent in UK, but you know, it's large labs touching of many different activities. So we are coming from them, in fact. So we have been working at very early stage to invent the technology of the processor, and so we are considered as a spin-off of this lab. As you can see, we have invest a lot to develop this technology or processor. So we have spent a lot of money and a lot of people, engineers and PhD to develop this technology. So it has been 10 years of huge investment, but at the end we have a very nice product. If we go to the next slide, please. Yeah. So as yeah, I think you can skip this one because it's
Okay.
kind of for something we already.
Not this one?
Yes, exactly this one. So yeah, and I will stay not too much technical, and this is perfect slide to summarize what is behind our technology, what is behind the Kalray processor. In fact, our processor, we bring 6 very interesting features, and one feature is of course the computing power, because when you are proposing a processor, you need to bring to your customer high computing capability. And but this is pretty simple to do that. I mean, all the big companies doing large processor are able to come with a high computing capability. What is more difficult is the others. Is, for example, the second is to do high computing, but in real time. And this start to be a little bit more difficult. So of course you can have high performance, but being able to do high performance in real time is start to be a little bit more complex. So now you start to minimize number of people who are able to, companies who are able to do that. Then the third item is also very unique for Kalray. Kalray architecture is specific in the sense that you can execute multiple applications in parallel and completely in parallel on the same chip. And this is very powerful when you have an application or when you have a product like a car. And today a car has a lot of computer in the car. And of course, you cannot afford to increase again this number of computers because you want to have new services like autonomous driving or assisted driving. So you really have to optimize your system first and reduce number of computers in the car. So today, if I remember well, you have on the high-end Mercedes, you can have up to 80 to 100 computers in a car like a Mercedes. So you really have to work to optimize that. And to do that, you have to use a processing technology which allow you to run multiple applications on the same processor. And this is very difficult to do that. And thanks to our architecture, Kalray is able to do that. And we can do that giving a guarantee in safety. And as you can imagine, in the car or in the drone or in a plane, it's very important to keep the safety and to rely on what you execute on the computer. The other thing which is important, of course, is low power. I mean, consuming less energy is vital for planet, but it has to be done at every level. So of course, our processor participate to reduce the consumption of energy. So we are bringing high performance, but to stay at low energy consumption, and this is very crucial for embedded application for sure. The other thing which is very, very important when you consider a processor is this processor you have to program it. You have to develop some software on it, and it's of course it needs to be as much as possible programmable, and it needs to be as much as possible open, in the sense that you cannot ask to a customer, okay, you can use my processor, but if you use my processor, you'll be locked with me for 10 years because I'm proposing you something proprietary, and if you want to go to my competitor, you have to change everything that you have developed with me. And so, of course, this is very important for a customer to give them an open system. And the Kalray processor is that it's fully programmable, and also it's open. And most of our software tools at Kalray has been developed based on open source. And the last but not least, which is very important, is the security and safety, of course. We're speaking about cars, we're speaking about drones, we're speaking about any other things, like even data center. We are managing data, personal data, private data. So the safety and the security is very important. And our processor brings that on top of all the other features. So we can skip this because this is more the detail of each item. But I wanted to at least give you an introduction of what is behind our technology and what is behind our processor. This is the roadmap. So we are so today we are in production with what we call a Boston, and we are moving to a new chip which is called the Coolidge. And this Coolidge has been designed to bring a lot of power computing, of course, as I told you before, and we've been focusing a lot of artificial intelligence because, as you know, today you need artificial intelligence in many different areas, and of course, our customers require to have a huge capability of processing this new kind of algorithm. And I think, do you have other things? So, I think for the other, it's more some detail about the market, but maybe I don't know. I think it's maybe sufficient for you, Abdul. I don't know if you, at least if you need more, we can go through the other slide if you want.
Well, I've got a few questions, so maybe you can go to the slide if you need to in order to illustrate your answer. How about that? Okay. One of the first things I thought of asking is probably a very simple question for other people to understand, but I know what real time is, and I know what whatever the alternative is called, I don't know, you know, processing in the cloud and, you know, getting answers later on. But can you elaborate a little bit on that for my sort of understanding, a better understanding of what real time means, what the difference is, and why it's why lots of people like you talk about it, and you know, as if it's crucial and it's new, and something that is a challenge, you know, in some ways.
It is a challenge, and it's a very good question because real time is really, let's say, general wording. What is behind, or what is very important, is what we call determinism. Means that when you execute an application, it behaves always the same. Means that whatever happening in the other area of the processor, when you execute, for example, you have, let's take an example of a car, you detect a pedestrian. And of course, when you detect a pedestrian, you have to take a decision very quickly. So you have to stop the car, or you have to turn or whatever, but you have to do something. And it has to be done very quickly. So then this is the time important. So of course you have to minimize this time. But you cannot afford to say one time the detection will take few milliseconds or few microseconds. And because my computer is doing something else, next time is going to do 1 second or 2 seconds. And of course, as you can imagine, 1, 2 seconds or 2 seconds, then you have an accident. So you have to ensure, you have to guarantee that what happened, whatever happened on your processor, whatever the processor is doing or processing other application, you need to detect the pedestrian always with the same time, and you cannot diverge from this, and you have to guarantee that. So this is what we call the time predictability, or the determinism. It's that you can guarantee that something which execute on your processor will take always the same time, or will behave always the same. And that's more than real time. So this is real time in general world, but this is what is behind. And to do that on the processor is very complicated. If you don't, let's say, if you didn't plan it, or if you didn't architect your processor from the beginning to do that.
Yeah, I think I understand real time. I just was wondering why it's such a challenge or talked about. I think it's because it is it's critical situations like that. The example you gave of the pedestrian and the car, it's something that's talked about quite often. And yes, it's understandable in a way. I even understand your comment about more than real time, because the processor has to kind of calculate even faster than real time, because will hold up real time if it doesn't. If it, you know, people have to, life goes on in the seconds that it's processing. It has to be much quicker than ever before, I suppose. But I suppose that leads me on to the other question I have about chip making in general. First of all, it's such a, I'm led to believe, I don't know much about this industry and the manufacturing and engineering, but yeah, I'm led to believe that it's such a complex and difficult thing to do, to design and manufacture processors. So just kind of curious about what your experience was. I know a lot of money has been invested and that solves a lot of problems. You can hire lots of people, but I was thinking of maybe one or two of the interesting insights that you might be able to give in terms of how do you go from basically, you know, no company to a company that makes the most complicated, sophisticated products anyone's ever built, microprocessors. What can you say about some of the experiences that your company
Sure. So first, we have removed the complexity of manufacturing because we are fabless. So that's a huge complexity removed. So we just concentrate on design, and that's the part that today Kalray is just focusing. And of course, as I told you, we start with this CEA, and the CEA is a lab who did a lot of study in the area of processing and in the area of processor, in the area of semiconductor in general. So they are very knowledgeable in this area. So working with them, it has been a way for us to be able to come with this new technology and invent this new technology quickly. Then, of course, most of the people working at Kalray are coming from other big semiconductor companies, because you cannot start to design such complex processor from only student or beginners. So we have a very high talent people at Kalray coming from different companies, from ST Micro, from Texas Instruments, from Intel. So we are a huge number of people which have a strong experience on this area, because this is the only way to be able to come with such a new technology after several years like us.
And the question of innovation in chip making, whereas before I used to think zeros and ones, processors just, from a very high level, from an outsider's point of view, it's kind of straightforward. It's almost like switching on and off electricity. It just goes through the processor and in bits and bytes and whatever. But but I'm led to be, again, I've been reading about this, and I'm sort of thinking that chips are becoming even more complicated and even more maybe application specific. So you're getting chips that are made specifically for artificial intelligence and other types of chips for other things. And I was just wondering what kind of, can you sort of give us an insight into the innovations, new things that maybe your company is doing that is along those lines?
So from the beginning, as we are coming from this academic entity, we've been working a lot with university and other labs. So, I mean, this is part of our DNA to innovate and work with other, let's say, other academic environment like universities. And also, we've been working years after years with our customers. And this is also something which is very interesting, is that when you work with a company like us, which is very agile and flexible in the development, because we master all our development from hardware to software, For customer, it's very convenient because then you can work together very closely with customers and define together what could be the best specification or best feature that we have to have for the next generation of the processor. So this is very powerful for us because we can make sure that when we come with new features, it has been validated by customers and it has been validated by the market that we want to address. And this is, for example, the way we've been doing for new generation processor, which will address the automotive. We have been working the past years with a customer from automotive, car makers or tier one, in order to define this new generation. And we explain what the technology brings, as I told you before, and then we also check with them what is needed, for example, for their next generation car. And this KaNN accelerator, this AI accelerator is exactly the kind of example that, of course, the automotive industry came to us, say, guys, your technology is very good, but I want to really bring high power, computing power for my AI application, because I want AI application in my next car. And so can you elaborate? Can you work on having such a things available? So this is the way we've been working so far, and we continue to work with our customer, closely with our customer and closely with the academics, so university, because of course, if you want to innovate, you have to be aware of what's happening in the research, and in order to take also the up-to-date technology, up-to-date brick of technology that you need for in your component.
Yeah, I'll have to get into learning more about chips and processors at a sort of more deeper level, because yeah, these kind of processors that you're talking about are very new. The one Kalray is got on its website, this AI processor. I don't know what makes one processor an AI sort of specialist type processor and another one a different type of processor. I'd be interested in doing that, but maybe I'll leave that for another time. But I wanted to go back to when you said about a typical car contains a certain number of chips. You mentioned a number I forgot, but I was wondering if you could elaborate on that. I think the example you gave was Mercedes, but I was just wondering, if you could sort of recap what you know about what you said earlier, and also what you know about cars in general, maybe, or maybe a specific type that you know of. What's going to happen going forward? They look like they're just adding more and more chips, and it's just going to become a bundle of like hundreds and hundreds of processors. You know, the car is not just going to become a computer on wheels, it's going to become hundreds of computers, you know, like loads of computers on wheels.
Yeah, it's a very good point. Maybe, Alison, can you go to a few slides after?
Back up?
No, after. Sorry, after.
Mm-hmm.
I think it's slide number again to this one, the one with the car,
This one?
No, above. Sorry, it's above because in fact I got this one. Sorry, yes, I got the image coming after. So okay, this one. So in fact. So you are completely right, Abdul. Today, in fact, a car is a lot of different process, a lot of computer working together, because each of them are, let's say, as task to execute, and basically new services, new feature arrive in the car, and the car maker just add a new computer. This was very basic, but this is what they have been doing today. And it was, let's say, possible to do that way because the additional features was not too much to add in the complexity point of view. But now we're speaking of replacing a driver. So you have to multiply by probably 10 to 100 times the capability of what a computer is today in the car. So maybe you have to multiply by 10 to 100 times number of processors in the car. And in the meantime, you have to add a lot of sensors all around the car in order to be able to analyze what is surrounding the car. And both, you cannot afford to have, I don't know, 10,000 cameras plus LiDAR plus radar. And on top of that, having 100, even more than 100 processor computer. So you have to rationalize your architecture. You have to think about, okay, now I'm not having one computer doing one task, but I need to have one big computer doing all the tasks in my car, more or less. And this is one concept that a lot of OEMs are looking now, is rationalize their system in order to simplify the system, and basically having a big computers or a big ECU, like they call it, an ECU, and having one super ECU which control everything in the car, and then just few other computer around the car to do some simple function to help this super ECU to work together, to work properly and driving the car properly. So this is a big change, and this is why for car manufacturer is really a revolution. What's happening is because it's not no more just I'm going to add a new function. No, I'm going to change completely the architecture of my car, because what I need to do is completely different what I used to do before. And also the other thing is that car maker, I mean, as you maybe probably have seen in the past, so I don't know, 10 years ago, there are some maybe 1,000 of code line of codes, and now it's million of line of codes for software, and they will it will be moved to even more, because software is everywhere, and they have to even increase the number of software in the car. So this change, it forced them to completely rethink and rethink about the complete architecture for hardware and for software point of view.
I really find this very interesting, this area interesting. So at the moment, there isn't a server in the car. It's like separate computers working together, but there's no central server at the moment. Is that right?
No.
Yeah. And that's kind of what you're talking about moving forward. Maybe there should.
Because, you know, there is today, yes, there is a server. This is the driver.
Yeah.
The server is a driver. So now you have to replace him, because you want to give some new services which maybe completely replace him, or at least give some assist to this driver. So you have to replace this server. And this is a new human, and the human is very intelligent compared to processor. So you have really to come with a very high performance computer in order to replace this driver.
It really fascinates me, this whole thing, technology in general, but this particular type of technology and what's happening. It's a very dynamic, fast moving. And
Yes.
As a last question, I wanted to ask you about the competition in the market. Obviously, it's a huge potential market. It's already a very, very big market. Lots of companies like yourself are, quite active, generating a lot of revenues. Can you give me your overview of the market and the competition and how you fit into all of that, please?
Yeah, I think today there is not so much competitor bringing same kind of feature than us. I mean, the way, the 6 point I listed before, it's very unique to Kalray. And this is why today we are interesting a lot of people. I mean, when I say a lot of people, we are today discussing with most of the OEMs around the globe, and also their tier one, so their supplier. So because let's say our technology is really unique in that sense, and answer a lot of their issues like aggregation or like high performance, exactly what is on this slide. So this is why, of course, we have competition, and of course today there are big actors coming in this, but having the same answer than us, bringing the same value than us, there is not so much, and there is no, in fact, having the same offer than us in the sense of value proposition for the car maker. So this is why today we really work closely with car makers to define the next generation and the next architecture of their system, and this is the way for us to make sure that we have the right technology to them. And we've been doing this work at early stage, and this allows us to now come with a new device, and this new device is the one that our customer expected. And this is more difficult when you are a big company, because when you are a big semiconductor company, you have a roadmap and you have a technology, and you know this technology, and you don't want to touch it, because if you touch it, then you impact all the people which are already using it. Just take an example of Intel. I mean, they are 20 years old, even more. I mean, it's a huge company. They've done so many things in the past. If Intel say, okay, guys, now I'm going to the car, I need to change completely my architecture. So then what will happen? They are going to lose their legacy, and they are going to say to their developer, okay, guys, we need to change everything on the software. So when you have a new company like us, it's very simple, because we start from a white paper, more or less, and then we invent everything, and then we work too closely with our customer to invent the right thing for them. So of course I don't want to say that we don't have competitors. We do have competitors, but today we believe that the technology that Kalray is bringing on the market is very unique, and give us a very big advantage compared to others.
Okay, Stéphane, thank you very, very much for your presentation.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.